So here we continue on with number 16. Going back to that picture that I began to draw earlier, if we did something like this, and put the N on the outside and the two carbons in the middle because they had the more bonding sites. Put the O up here on this carbon because we know it's a potential candidate for a double bond. All right, so now we have 20 valence electrons. 4, 5, and 6 makes 4 plus 1 is 5, plus 6 is 11, plus 4 is 15, plus 5 is 20. Take away 2, 4, 6, 8, so I've got 12 to put in. All right, so if I do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, you see that I still need 6 more for the oxygen. So we said if we were too short, we would add a double bond. And if we had 4 electrons too few, we needed 4 more than what we really have. We had either a triple bond or 2 double bonds. This time we're 6 short, so we're just going to keep going. So we'd add either 3 triple bonds or a double and a triple. So where could we put such a thing? I think the candidates for a double bond would be right there. And make that very clear. Let's erase that. Go back. All right, so the double bond, make that, oops, don't want to do that. So that's oxygen, and then we had a double bond here if you did that. Okay, you put a double bond there, that would pretty much fill up the carbon here. This carbon could be, you could put a triple bond on that, like that. So let's redraw that, or at least take off the electrons and reconsider our electrons. All right, clean up my diagram a little bit. So now, I've got, instead of 8 in the picture, there's 2, 4, 6, 8, 10, 12, 14. So I'm going to take away 14, gives me 6 dots to put in. So I would need 2 here to make the nitrogen have 8. The carbon already has 8, 2, 4, 6, 8. The oxygen has 2, 4, 5, 6, 7, 8. So now I've used all my electrons, but all of the outer shells are satisfied. So that's our picture. Now that one has 3 pi bonds because here you got a sigma and a pi. Here you got a sigma and 2 pi's. So there you have your 3 pi bonds. Now that one's a little harder to draw this picture than most of what we did. But these, you know, can't be the answer, so by elimination you can go back to A. All right, uneven sharing. Uneven would be what? Polar or nonpolar? So if they're sharing unevenly, they're going to have a positive end and a negative end. Which one of these has bond angles less than 109.5? Once again, you got to draw your dot diagrams. All right, so this dot diagram has bond angles of 120. It's trigonal planar. You may remember that boron does not obey the octet rule. So if you had put a double bond in here, the formal charge wouldn't be as good. So you don't put a double bond in on boron. This one, bond angle is 109.5. This is a tetrahedral. This one, that bond angle is 180. But here, the unshared pairs, they tend to spread out a little bit. So the unshared pair up here spreads, and that spreads too. Since they spread out, that pushes these bond angles down a little, these bonds here a little bit closer to each other and makes the bond angle go down to about 104.5. And that's your answer, A. Okay, square planar. Did I have that question earlier? You have to draw a dot diagrams for that. Yeah, maybe I didn't. I thought I had that earlier. So, anyway, the square planar is going to be the XEF4. You have to draw all the dot diagrams again, so looks like that. Oops, that's supposed to be an F. I'm going to leave off the unshared electrons. So there's your two tetrahedrons, BRF4. I'm just thinking about that one. So that's 7 times 4 is 28, plus 5 is 36. There's two answers on this, I think. So BRF4 would be BR. You have 36 valence electrons. So you put in 8 of them, so you get 28 to distribute. So you put 6, 6, 6, and 6. That gives you 24, so you have 4 extra. So the 4 extras are going to go around the center. So here and here. So that's a square planar, and this one also is a square planar, the same number of valence electrons. So the answer is either C or D. I would take both. And the molecules listed number 19, which have sp3 hybridization. Let's see, sp3 would be this one, 4 domains, and this one, 4 domains, so A and B only. Which exhibits resonance. So first of all, you're going to want something that's molecular, so that eliminates this one because that's ionic. You want someone, like you do CH2O, you know you're going to have an H and an H like this, and so you can't put double bonds on them, so that's out. Carbon dioxide, you know, already has 2 double bonds, so there's no resonance because you can only have 1 double bond. On BRF3, that's a T shape, so BR then F like this. So you have 7 times 3 is 21, and 7 is 28. Take away 6 is 22. So you got 6, 6, and 6 is 18, 19, 20, 21, 22. So the answer is D. Here's why. When you draw the dot diagram for D, you're going to find out you have this structure. And the sulfur is 6 and oxygen is 6, and so there's 24 valence electrons. So take away 6, you got 18 to put in. You put them in here. So you have an extra, you need 2 more than you have, so what do you do when you're 2 electrons short? You add a double bond. Where do you put the double bond? Well, it could go here, or there, any of those places, and so that's what resonance is. 22, which has no pi bonds. No pi bonds would be the one that doesn't have any double or triple bonds. So if you draw the dot diagrams, the only one that will do that is NH4 because it has 8 electrons. You got 5 plus 4 is 9, but a plus 1 means you've lost 1, so you got 8. So then, since there's no double bond, there's no pi bond. T-shaped. I drew that one up here a minute ago, so that's BRF3. All right, which one involves moving metal, electrons from metal to non-metal? Ionic. Which could involve sharing electrons between 2 atoms in a molecule? That would be covalent. And you could also make an argument for network covalent on that one. Which one involves sharing electrons unevenly between 2 atoms? That would be polar covalent because they're making little poles. And which of the following involves sharing of electrons in a molecule? Could also be nonpolar covalent bonding. So, or polar. Oh wait, it says even sharing. Sorry about that. That's nonpolar. So that's your only answer is nonpolar. All right, that's the end of that little thing. So I'll post this video, and hopefully it helps a little bit. Remember, the test will also have a grid where you have to draw the dot diagrams with the resonance, or with the formal charge and all that kind of stuff that we've been doing on your 53 dot diagrams.